We're surrounded by materials we trust without a second thought. And one of the biggest is borosilicate glass. It's in our coffee pots, our baking dishes, even in high-tech labs. We see it as the superhero of glassware. But it turns out even superheroes have a weakness. Let's dig in and find out what it is. So you've got this stuff in your kitchen, right? You probably chose it because you thought it was basically indestructible. We pour boiling water in it, we bake with it, we freeze things in it, all without giving it a second thought. But is that confidence really earned? Well, the answer is a little more complicated than you might think. Okay, so let's start with what everyone believes. We've all heard it. Borosilicate glass is the tough stuff. It's the gold standard for handling heat and for being chemically pure. And, for a lot of good reasons. Its reputation was built in some of the most demanding places on Earth, like science labs. Yeah, these are the words that come to mind. Strong, heat-resistant, reliable, the undisputed hero of the kitchen. This is the idea, the myth that we all have in our heads. But today, we're going to pick that myth apart, just a little. And here we go with our first big reality check. For all of its amazing heat-resistant properties, at the end of the day, it's still glass. And that means it is absolutely not immune to a good old-fashioned drop or a hard knock. This is the key thing you have to understand. Borosilicate's superpower is its thermal toughness. That's its ability to handle sudden temperature changes. But when it comes to impact resistance, like dropping it on your tile floor, it's basically the same as a regular old glass jar. It's just as likely to break. That's a huge difference that most of us just don't realize. And this weakness can be really sneaky. Just imagine you're stirring your coffee in a glass carafe with a metal spoon. That little clink might create a tiny microscopic scratch on the inside. You'd never see it. But what you've just done is create something called a stress concentrator. Now, all the normal stress from heating and cooling focuses right on that one tiny spot, making a sudden, totally unexpected break way more likely down the road. All right, on to danger number 2. And this one is completely counterintuitive. We think of borosilicate as being perfect for the freezer, don't we? But the real danger isn't the cold temperature itself. It's what happens to the liquid inside the glass when it freezes. There's a scientific term for this phenomenon, breakage. And this isn't a failure caused by the cold seeping in from the outside. No, this is a failure from an outward pushing force. It's basically an attack from inside the container. So here's what's actually happening. When the water inside starts to freeze, it expands by about 9%. And all that new volume has to go somewhere. So it pushes out relentlessly against the walls of the glass, creating this huge internal pressure. It puts the glass under an incredible amount of stress. And this is what happens. See that? A clean, distinct, vertical crack. That is the classic signature of breakage. It's not a random shatter pattern. It's the physical proof that the glass failed because of that uniform outward pressure from the ice. It's a pressure break, not a temperature break. Okay, so let's talk about the danger we all think we know about, thermal shock. This is our third danger, and even here, this supposedly invincible glass has very real, very specific limits. Let's see how this kind of break looks different from the one we just saw. So the key is to look at the cracks. A pressure break from freezing, like we saw, leaves that clean, vertical line. But a thermal shock break, which is caused by a really fast temperature change, leaves a completely different pattern. The cracks wander all over the place, kind of meandering, because the stress is uneven as different parts of the glass expand or shrink at different speeds. And you can see the difference so clearly here. Just look at the two. On the left, there's that straight, clean break from internal pressure. And on the right, that chaotic, wandering web of cracks from thermal shock. By looking at the pattern, scientists can tell you exactly why the glass failed. So what's the magic number? What's the limit? Well, research shows that a sudden temperature difference of about 18.3 degrees Celsius, that's 330 degrees Fahrenheit, is the breaking point. So yeah, taking a dish straight from the freezer and putting it in a blazing hot oven could easily cross that line and cause it to shatter. But not all the dangers are so explosive. Our fourth danger is a much slower, more sneaky threat, especially if you're storing something for a long time. Over time, the actual surface of the glass can start to break down. Listen to how one of our sources describes it. It talks about visible, shiny, needle-shaped particles appearing in the liquid. This process is called delamination, and it's basically a chemical attack on the glass itself, causing these tiny flakes to peel off and float around. It's a huge deal in the drug industry, but the basic chemistry can happen in other situations too. And here's something that might surprise you. How you use the container makes a huge difference. Studies show that a container that's only partially full corrodes way faster. A vial that's only 30% full can show more than 3 times the chemical breakdown as one that's 90% full. Why? It all comes down to something called the surface-to-volume ratio. So what's the practical takeaway here? Well, that half-empty large container has a much higher ratio of wet glass surface compared to the amount of liquid inside. This just speeds up the chemical reaction and the corrosion. So if you want long-term stability, it is absolutely crucial to pick the right size container for the job. So, after going through all these hidden dangers, what does it all mean for you? Well, it's about understanding the whole picture. For example, while the finished bowl in your kitchen is perfectly safe, the process of making it can involve hazardous stuff like crystalline silica dust. It just reminds you how complex even our everyday objects are. So here's how you can use your super glass like a pro. First, just remember it's not invincible. Treat it with care and try not to drop or scratch it. Second, if you're freezing liquids, always leave plenty of room at the top for that 9% expansion. Third, avoid those crazy temperature swings. That thermal shock limit is very real. And finally, when you're storing things, a smaller, fuller container is always going to be better than a big, half-empty one. You know, this deep dive really shows us that even our most reliable materials have limits. They have vulnerabilities. It kind of makes you wonder, doesn't it? What other super materials that you rely on every single day might have hidden weaknesses that you've just never even thought to ask about? Something to chew on. Thanks for watching.